Hello, my friends. So, we are back with another part, and over here, we're going to discuss the subset sum problem with dynamic programming. So, the problem statement that we have to solve in this problem is that we are given an array. So, this is our input array, and check we have to check if any subset in this particular array has a sum of target 13. So, what the question exactly says is, first of all, you need to know what is a subset. What is a subset? So, subset is subset is the combination of all the elements present in this set in any particular manner. For example, the combination of one, sorry, let's type it again. 1, 3, and 5 is a subset of this array, and a combination of 1 3 is also a subset of this array. 3 1 is also a subset of this array. So the only the elements matter. Their positioning, their respective positioning does not matter in the case of subset. And 1359 is also a subset of this array, and an empty array is also a subset of this array. You have to understand that if the target is given 0, then it always will be a possible subset sum for the given question, because empty array is always a subset of every set. All right, you have to remember this thing in computer science. It is a very basic thing, so you have to know it, that empty set is always a subset of a given set. All right, so now we are going to see how to solve this particular question with the given examples. So again, we are using dynamic programming in this question because it is a choice based question. And how do I know it is a choice based question? I'll explain it to you in a minute. That so whenever we are seeking like the possible subset sum for this given input array, so we have two choices. We are keeping the pointer here, or we can keep the pointer here. If you want to go backwards, let's try backwards in this question. So I'm drawing it here: 1 3 5 and 9. So let's see. If I am keeping the pointer here I, then I have exactly two choices. Let's keep a current sum array, which will be 0, or rather let's keep um, or rather let's keep the target sum that we need. We're going to subtract each element we choose from this sum until it reaches 0. So we are going to subtract all these numbers that we select from this particular number until the final number results in 0. Because if we subtract these numbers and the number we finally reach is exactly 0, that means the sum of all these numbers also tend to be 13, or the target element. So we have exactly two choices when we are traversing the array. Right now we are at 9, and we have two choices. What are those choices? That either we can pick 9, or we cannot pick 9. All right, so let the left choice be we will not be picking 9, and the right choice will be we will be picking 9. So if we do not pick 9, then we are not subtracting anything, so the target element is still 13. And if we do pick 9, so we are subtracting 9 from 13, so now the new target is 4. All right, so the what you can understand is the base condition in this will be either we the I reaches here, that means the array is finished, or the another base condition will be if there is an element 14. All right, if there is an element 14, so can this any element be included in any subset of positive integers? No, it cannot be, because if the element 14 has value greater than the target sum, then the subset will never reach the value of 13, because the only element, the one element we are picking, has the value of greater than the target value. So we are not going to pick any value that is greater than our current target value. So in this condition, we are at 9 and we have decided we are not picking 9 and we are picking 9 in two different conditions. So we'll decrement our I and now we'll bring it to 5. So let's first go here in the left subtree. So here we have two choices. We can either not pick I or we can pick I. So if we do not pick I, then the target sum remains 13. And if we do pick I, that is 5, the target sum becomes 8. Then we will reach our right subtree. So over here, let's decide two things. So if we do not pick I and if we pick I, so the thing is here, let's see that if we pick I, if we decide to pick I, we encounter a base condition. What? That 5, that is the current element, is greater than the target sum, the current target sum rather. So 5 is greater than 4. So it cannot be picked up because the new target will reach -1 and there is nothing we can add to this to reduce it to 0. All right, because it is already -1. I hope you understand this. So we will, of course, not pick this, and the target sum will remain 4. Let's see. Then we will move to the, we'll move our I to 3, and here we can and cannot. We cannot pick 3, and we should pick 3. So if we do not pick 3, the 13 retains, and if we do pick 3, then the answer is 10 now. And in 8, if we do not pick 3, the answer is still 8, and if we do pick 3, then it becomes 5. All right, so in 4 also we have two different choices. So this tree is neutralized over here. We're not going to do anything with this because it has reached -1, which is less than 0. So we are not going to continue this. All right, so here we are at 4. Here we are at 4. So we have two choices. We are not picking 3 and we are picking 3. So if we are not picking 3, the answer will remain 4, and if we are picking 3, then the current target sum will be 1. Then we have another choice. Then we move our I backward. This is the final choice. So we move our I backward. So I is right now at 0th index. So let's continue with the leftmost subtree. We are not picking I and we can pick I. So if we do not pick I, the answer will remain 13, which is not equal to 0. So this tree does not contain the answer because in the next condition we are moving to the base case, that is I is less than 0. So we'll terminate the program over there. All right. So if we are terminating the program, this is the last thing, that this is the last, like the leaf node now. So if we do pick 1, then it is 12, which is again not equal to 0, so terminate it. Then over here also we cannot pick and we do pick. So if we do not pick, it's still 10 and this is neutralized. And if we do pick, it's 9, it is again neutralized. And at 8 we can are not picking and we are picking. So if we do not pick, then it will be 8. And if we do pick, then it will be 7. So both of them are neutralized, and this 5 is also neutralized because if we do not pick, then it's 5, and if we do pick, then it's 4. So at this 4 also there are two choices. We are not picking, we are picking. 4 and 3, these both are also neutralized. But at 1, if we do not pick, then it is 1, which is neutralized. But if we do pick, then we reach our target 0. So we are reaching 0. Hence, there is a subset in this particular array present which has its sum equal to a target element, which is 13. So if it is equal to 13, then we are returning true. The question does not ask us to print this particular array or this particular subset. So what will be a subset we can determine from this tree. So at 13, the first element we encountered is 9. We picked that element and we reached 4. So we have picked 9 and we have reached 4. Then we are not picking the second element, that is 5. We are not picking 5, so we will not include 5 in this subset. And then after 4, we are including the third element that we are at. So this element will be 3 and we are including it, so there will be 3. And if then we consider 1 and then we are picking the last element, that is 1, so our answer will be 0, so 1. So this will be our particular subset. So this will be our answer subset. There are no more subset present because I have explored all the choices. But in reality, when you put a base condition, that is current sum equal to 0 and return true, if this is the base condition that you put in your question, then the first thing, whenever the this tree reaches 0 as its answer, then it will not reverse anything else. I hope you understand. It will not reverse anything else. It will just return 0 and end everything, because we are not we are not asked to explore all the solutions. We are only asked if there is a single solution present. So whenever we reach a single solution, we return yes, there is a single solution present to this question, and end and return the function. That's it. So we are going to do this, and we are going to use dp, because as you can see, it is a tree forming, and which gives us a time complexity of 2 to the power n, because we have two choices. If we had three choices, then the time complexity would have been 3 to the power n. All right. If we had n choices, then time complexity would have been n to the power n. But we are using dp in this, so the time complexity become n square in this particular condition. I hope you understand this. So what happens is, in dp we do not like execute the same result twice. That is, if we are doing this and this occurs again, that is, if we are doing 13 and this occurs again, then we will not compute it again completely. To save time, to save space. So, friends, this is the question we have been talking about on the whiteboard. Now we'll solve it on Geeks for Geeks. I will give this description in this URL in the description box. So, let's start. I would recommend you try to solve with me. So, we have already discussed that this is a DP based question. So, like all the other questions, I'm going to create a new function which is going to return an answer. But this time, this all is demanding Boolean variable. So, there is one problem which we have to face when there is a Boolean variable in demand in return. So what is this that problem? The problem is that dp variable can only be like the dp array, a boolean dp array can only have two possible values, true or false, and both of those values can have your effect on answer. So we cannot initialize the dp array with a value other than these two values, because these two values may be a part of the answer beforehand. So that's what the problem is. So we are going to convert this to an int, and how we are going to do it? One, the value 1 in integer form stands for the true, and the value 0 stands for false. So I'm going to return or rather I'm going to type int answer is equals to helper function. I'm calling a helper function, and there goes the n, arr, and sum. And if this answer helper function returns 1, then return true, else return false. So we create the helper function over here, static int helper, with the int n as the number and int arr as the array, and int let it be target for the target sum. So let's remember the base conditions. What were the base conditions? So if our n equal to 0, it should be less than 0, but I am already passing the size of the array, so the index runs 1 below that. So what we'll do is we'll use n minus 1 as our current pointer. So if n equal to 0, that means we are out of the array, because n minus 1 will be equal to minus 1, which is not index in the array unless it's Python. So where here we're going to return 0, because it will be false. as we are already outside of the array and the other base condition is not checked yet. The other base condition will be target equal to 0. So if a target equal to 0, then we'll return 1. That means we have already found the target element and we only have to return 1 and return true over here. So uh, the next condition will be if the weight of the current element, that is the current element is n minus 1, is greater than our target, then what will happen? Then we will skip that element because we have no other choice. Will have to skip that element. So what we'll do is we'll put here n minus 1 and arr and target, because we are not subtracting anything to target, because we are not selecting the element, we're just skipping the element. So I have skipped the element over here. So the last return will be our two choices. And how will those choices occur? Then I have to write the first choice will be the same as this choice, because we are again not selecting the element, but there will be a single little twist. So we cannot use or over here because this is integer elements and this only works for boolean. All right, so what we'll do is we'll put here not equal to 0, and I'll type the other equation so that you know better. Helper, I'll explain why I have put this over here. Actually, I put this over here to allow me to use this operation, that is or operation. So I'll come back to it in a minute. So n minus 1 in this condition as well, arr, and target is reduced by the current element I am standing on, arr of n minus 1. All right. So what happens is I have to put here is not equal to 0 as well. So what happens is that directly if we use this operator, the question will give us an error that int and int cannot be determined using this operator. But over here I put this value if it is not equal to 0, that is if any of this is 1, then what I'll do, I'll put an if return 1 or else return 0. I hope you understand this. Question mark is an if, and the first element is the condition of if, and the second element is the condition of else. So this statement over here reads that if this helper function call or this helper function call, if either of these helper function calls return 1, then we will return 1 as well. Or if neither of these functions return 1, both of them return 0, then we'll return 0. And the answer will be false. So let's compile and run this. Let's see. So this is our answer, and let's submit this. This is without using the DP, and I'll use DP in a second. If this, so the time limit has exceeded, that means the question is giving us a requirement to use DP. So if we have to use DP, then again this helper function is returning int. The only two changing variables are in and target. So we'll create the DP based on these things. So int 2d DP, int DP equal to new int. The first changing element is n plus 1. So because we have to go till n, then the second element will be sum plus 1 here, and let's fill this DP for int I equal to 0, I is less than n plus 1, I plus plus, and then for int j equal to 0, j is less than sum plus 1, and j plus plus, and dp of I j equal to minus 1. So I'm putting minus 1 inside the to the dp because like I've already told you, it will be a parameter if we have already solved for the element or not. So I am passing this dp over here, then I'm receiving this dp over here, and what I have to do is, I have told you multiple times, wherever we have return something, there we have to put dp of the two changing variables. The first changing variable is n, and the second changing variable is target. So equal to. So what we are doing again here is we are returning 0 as well as storing 0 in this index of dp. So I'm going to do it here as well. So n and target equal to 1. Again, here we are also returning something. I have not put return over here, but either case we are returning the helper function over here as well. So we'll again put n and target, and we'll store it in the n and target index of the dp and return it as well. Then again we'll put here dp of n and target equal to this. And unlike the other questions, we'll pass the parameters first, then compile the question. So I'm passing these parameters. So let's compile it first. Oh, I have not put the -1 condition. So I have stored it in dp, but I'm not checking if I've already solved the dp or not. So if n and target is not equal to -1, then return dp of n and target. I will put this up here before the second recursion to reduce time. Let's compile it again, and let's submit it. Let's hope this time it works. Alright, so So, the problem that was occurring in this question is that I had actually put this condition, the target condition, over here. So what was happening is I took a lot of time figuring this out. So it was such a small problem that if our n equal to 0, that means we are out of the array. But we haven't checked the target yet. So it is already returning 0 over here, but we have not checked if the target at this point of time is already 0. That means we have already gotten our answer from the last equation we have already solved. So this is over here. If this will be over here, then we will submit this question and let's see. And now this is processing all the test cases and it is working. So the time has been drastically reduced. So this is the complete solution of memoization for subset sum problem. Then there are a few new things that you can add to the problem. For example, that the question may demand if we have to return the exact subset which we are using for the given target sum, or the question can also say give the number of subsets that result to this target sum. So in the second condition, what we will do is we will not return it. We'll just keep storing it in dp, and then over here we'll traverse the whole dp, and whenever we get a 1, we add to the target. That is a new variable that is initialized to 0, and whenever we get 1, we'll add it to the variable to check if how many elements, how many subsets are actually giving the correct answer. And the for the first question, it is a bit more complicated. It will use backtracking, so I'll explain it to you in later examples. So this is it. I'll continue with me for part 5, and let's go right now. Thank you for watching the video.